Welcome to the HPC on Intel Software 101 course as part of the Intel on HPC Solution Competency. I'm Steve Stein, Marketing Specialist for Intel, and in this course we're going to try to go a little bit deeper into what the Intel software tools are and how they optimize different software applications out in the marketplace. What do I want you to get from this course? I really want you to be able to compare, again, optimized platforms of hardware and software for very specific customer needs. As we said in previous courses, not all HPC workloads run the same. We want to make sure that you know that the different hardware and software configurations, in this course particularly software, that's going to be used to help optimize those applications. So we want you to be able to explain the value of Intel software for very specific HPC workloads, and we want you to talk to your customers about how that optimized software is going to deliver the best performance for those HPC workloads. And we also want you to be able to make recommendations of certain Intel tools and certain Intel technologies for your customers in case they're not already taking advantage of certain Intel tools or software packages that could help them get the most out of their HPC applications. And so for this course, we're going to be going through, again, what are some of the software optimization needs for certain workloads, and then we're going to go deep into what are the actual Intel tools and how they add value for applications. And then we're going to go through a summary and next steps. So let's start with what are some of the software optimization needs and implications for different HPC workloads. So we've shown this slide in previous courses, but we want to keep in mind that, as the HPC ecosystem is evolving, today and in the past, it's very much, I have this certain workload, I have this very specific vertical that I work in, so therefore here is your recommended HPC cluster, your very specific tuned app and software specifications. We are starting to move to this world where clusters are going to be generalized. They're going to run traditional HPC workloads, they're going to run AI, they're going to run high-performance data analytics. So it's important to have a flexible system and a system that has a range of menu options to be able to deliver to customers the best performance. And you should be talking to your customers about how this ecosystem is changing so that they can use their clusters to run AI and run high-performance data analytics, and remind them that Intel is building optimizations not only into traditional HPC workloads, but also into AI, also into data analytics, so customers can reuse their clusters for these high-performant workloads instead of having a system designed for one workload. And keep in mind that HPC is evolving and expanding not only in scope, in terms of adding in analytics and AI, we're always expanding the scale. Intel is pushing closer and closer to exascale, and actually Intel did win the first contract to deliver exascale performance with the Aurora compute system delivered by the Department of Energy. Also, the delivery models of HPC is changing as well. It's not going to only be on-prem systems. It's also going to be delivered through the cloud as well. So keep in mind as customers start talking to you about what are the different types of delivery systems that are coming as well. Intel is adding unique value and is leading the way in all three of these categories. And building in analytics and AI into the clusters, always expanding the scale, and making the push towards HPC in the cloud. And we've seen this slide in previous courses too. Keep in mind that we're always trying to increase that work over time, maximizing that for HPC value for your customers. In this course, we are going to zero in on what are those Intel tools, what are those Intel software packages, and our relationships with the ecosystem that's going to be able to drive the best optimizations and performance into HPC workloads that your customers are using. And so here's an example of some of the areas we're going to go deeper into. What are some compilers? What are some math kernel libraries? What are some parallelization and scaling techniques that our tools are focused on to help deliver the best performance to your customers, as well as what are some of those direct relationships that we have with ISVs to be able to deliver those optimizations, again, directly into those codes so your customers can use them. So now let's go into the actual Intel value add for software for HPC applications. So as a quick reminder, here's the larger Intel value add, kind of the why Intel for HPC that you want to remember as you're talking to your customers. We provide exceptional hardware with acceleration built in to those platforms, provide exceptional software, which we're going to go deeper into in this course. What are our relationships with the ecosystem? And of course, we are the most trustworthy provider of HPC systems into the marketplace. Again, we have over 95% share of the top 500 systems in the world, and we're driving towards the first exascale system with the Aurora supercomputer, as well as delivering the best debugging and analysis tools for our customers so they can be assured that they get the best performance and workable systems on Intel. So let's dive into the software a little bit more. You've seen this slide in previous courses. For Intel software, we are going to be focusing on the tools that help you build, analyze, and scale codes. So we have tools and software packages that fall under all three of these categories. And for ecosystem development, we are going to be showing you how we have, again, those direct relationships with ISVs. So as we develop software tools that optimize very specific applications, we are pushing those optimizations directly into those ISV applications so your customers can be sure they get the best performance running on Intel systems. And I do want to take a quick step back to let you know, why is software important for HPC? So as a customer is trying to get value out of their HPC systems, this customer is going to be bringing together data which exists on their site. They're going to be buying hardware recommended by you. They're going to have a very specific business scientific use case. But those three things by themselves do not give you value. You need to have software to kind of glue all that together. So you're applying software towards the data to be fed into the system, which is applied to that very specific use case. And that's where you get value. It's incredibly important to make sure we tie all this together and that you actually get that optimized performance, because the hardware by itself is not going to deliver value for your customers. So we really need to look at how software converts all these pieces into tangible value for the users and the customers. So it's important to understand what these tools are. And so how Intel categorizes the tools and the software packages that it delivers to the market, we like to break it down between three different categories. Build. So this is going to contain all your tools to help you build the most performant application that you can get. What are the optimizations you're actually going to build in to get the most out of the hardware that you're running the applications on? Analyze, to help you debug and figure out how you can fix certain code inefficiencies to get the best performance that you can get. And then scale, which allows you to take advantage of multiple nodes, allows you to take advantage of the cluster to be able to scale the code across multiple nodes, so you either get more work done in the same amount of time or the same amount of work done in less time by being able to scale across those multiple nodes. And it's important to note that Intel adds unique value into the ecosystem where it's needed to be able to optimize those software applications. And so let's categorize and actually look at what are the different Intel tools. So inside the build category, we have things like Intel Compiler, the Intel Fortran Compiler, distributions for Python, math kernel library, threaded building blocks. These are really going to help your customers build the best applications they can. It's going to help ISVs and developers build the best applications that they can. And keep in mind, Intel, again, is feeding the best optimizations to those developers, so as they release the code to their customers, they get the best performance. Also, Intel has made a very large investment into AI, artificial intelligence, and also high-performance data analytics tools to make sure we get the best performance out of those workloads as well. So for those customers that want to run AI and high-performance data analytics on their clusters, we have that optimization already built in from Intel. And in the analyze category, we're really looking at how we're trying to take apart the code, analyze different components of it, figure out what is inefficient about it, and how we can actually suggest fixes for that. This is going to be very helpful for developers and people actually writing the code themselves, so they get the best performance that they can by actually analyzing the code. And then after you built it, after you analyze it, now you want to scale it across multiple nodes. That's where Intel MPI library comes in. That's where OpenMP optimizations come in based on open source optimizations. And then also allowing you to actually analyze your cluster to figure out if you're getting the best performance, the most efficient performance after you scaled your code. So let's dive in a little bit deeper into all these categories and figure out how Intel actually optimizes performance. So on this slide, I want to give a little bit more information about what these tools are actually doing. What are the actual performance increases you're going to see compared to competitive tools that are out in the marketplace today? So our compilers are world-class. We actually give substantial performance increases over other compilers used in the marketplace today. Our math kernel library provides very specific optimizations to math operations that are used in a lot of HPC codes. And again, we're investing very heavily in making sure that data analytics tools and artificial intelligence tools and frameworks are optimized specifically for Intel CPUs. So customers, again, have that best range of options to pick from to help build their clusters and get the best performance for their applications and their use cases. In the analysis bucket, again, we're looking at things like the Intel vTune amplifier to help profile what the performance is looking like, Intel Advisor to see if we're actually getting the right vectorization and the right thread optimizations inside your code and to make sure it's running optimally on the CPUs themselves. And then with Intel Inspectors, really taking a closer look at the memory and the threading debugging to making sure that the memory is being fed into the processors in the best way to get the best performance. Then on the scale side, with the Intel MPI library, what Intel MPI is doing, and it stands for Intel Message Passage Interface, what it's actually doing is it's looking how to effectively chop up your code so you can effectively parallelize it and then run it across multiple nodes. It's a very complex process, and it's actually something that a lot of developers strive to get the best parallelization that they can so they can actually scale across multiple nodes, and then getting that efficiency built in too. So as you scale it across multiple nodes, you're getting very efficient, strong performance so you can take advantage of your whole cluster. And then we actually give you tools to help analyze, is that scaling happening efficiently? Are there different types of bugs? Are there different types of inefficiencies built into it? And then recommending fixes to help you figure out how you can run your cluster the best. And so these are actual tools that we're providing to the marketplace. Let's go through each one in a little bit more detail. So Intel compilers. So for those of you that don't know what a compiler does, what it accomplishes is you have written code from a developer, like C++ or Fortran, executing a certain operation. Compilers actually take this code and then translate it into ones and zeros so that the CPU can actually execute its functions. That's a very complex process and actually takes a lot of compute resources in order for that to happen properly. Our compilers do it the most efficiently out of any other compilers in the marketplace. And our compilers actually do leverage C and C++ and Fortran language, as well as plugging into OpenMP standards, for those codes that want to leverage more open source tools to be able to get the best performance out of the compilers. For the math kernel library, so math operations inside of a CPU are not automatically optimized. Like if you go back to your days of working on, say, like a TI-83 or some of those graphing calculators back in the past, some of the more complex math operations are not very efficient on a CPU unless you specifically program that in, or if you make the CPU very efficient in operating for it. So if you're running something like a fast Fourier transform, or if you're trying to do certain vector math operations, these things are not automatically optimized into the CPU. Intel actually has to go in and make sure that linear algebra operations, again, those fast Fourier transforms, that vector math, is optimized for very specific applications. So if you're looking at fast Fourier transforms for something like structural analysis, or if you're looking like vector math for something for artificial intelligence, or linear algebra for computational fluid dynamics, these things have to be optimized for the codes as they're running them. And the better you get it optimized, the more performance you're going to get. It can also bring in things like Intel AVX 512 operations. It can bring in more advanced operations for AVX2 if the code can't take advantage of Intel AVX 512. But Math Kernel Library is an incredibly important tool as third-party ISVs are looking to build their applications and get the best performance out of these math operations that are very complex. And for artificial intelligence, this has been an area that Intel has been investing in very heavily over the past few years to make sure that artificial intelligence operations, artificial intelligence workloads, and applications run very efficiently on Intel CPUs. There is a myth that exists in the marketplace that AI cannot be run on CPUs and it can only be run on GPUs. And that talking point is false, because Intel has poured, again, a large number of investment into making sure that the software optimizations, the software performance on a CPU has dramatically increased over time. And what we're looking at on this slide is the direct investments that Intel has made into AI frameworks and AI topologies to make sure that we get the best performance. So if you look at this slide, when the Intel Skylake processor launched, so this is the first gen Intel Xeon Scalable processor back in July of 2017, it had a certain baseline of performance for AI. And then when we started ingesting different optimizations into the CPU, we saw a 50x gain in that performance on AI applications between the launch and when we started introducing those optimizations. And then between July of 2017 and February of 2019, we just kept pouring more and more investment in, and then we got up to a 285x improvement over that original baseline. So we're talking about orders of magnitude improvements in terms of the AI performance that's actually happening on the CPU. So if your customers ask, wait, I can't run AI on a CPU, I can only run it on a GPU, why should I care about CPU performance on AI? Remind them of the investments that Intel has made to show them that we get great performance with artificial intelligence on a CPU. So this goes back to, you should be reminding your customers, hey, don't just run high-performance computing applications on your clusters. Look to run AI. Look to run high-performance data analytics because of the optimizations that Intel has actually built into the CPU for AI performance. So now let's go over to the analyze and debug category to figure out what are the different types of tools that Intel is providing to help customers and developers debug and fix inefficiencies inside their programs. So for the vTune amplifier, we're really looking at how are we optimizing the CPU, the threading, the memory, the cache, the storage to really try and get the best performance that we can out of the CPU and out of the hardware itself by really diving into, is the program parallelized correctly? Are the different threads operating efficiently? Is one thread taking up more resources than another? And it's really able to kind of visualize what's happening inside of the code so that developers can go in and fix it. This is invaluable for those developers and for those coders and for your users that want to get the best performance out of their systems. So with Intel Advisor is another analysis tool that really helps you dig into, is your code threaded and vectorized appropriately to get the best performance? If we just compare performance to a standard serial operation, so if you're just running the code on one core as an example, you're going to get a certain baseline of performance. But as you start to vectorize, as you start to thread that performance and adding more threads to the actual application itself, you're going to see massive improvements in performance. And this Intel Advisor is going to allow you to see, is your code vectorized appropriately? In other words, is it using Intel AVX 512? Is it using AVX2 for efficient performance? Are you getting that efficient memory access? Is it threaded appropriately? Are you getting the maximum use out of the CPU threads as possible? So it's able to give you that analysis. It's able to give you recommendations for how you add in and optimize that vectorization, as well as analyzing different memory patterns to give you the best performance. So this is invaluable for those developers that are going out and optimizing their code on Intel platforms. And so we want to give you a data point of how these analysis tools actually do impact customers' bottom lines. So it does increase ROI between 12 and 21% to actually go in and try and figure out where is the code operating inefficiently so you get better performance. This is kind of show, the value, again, that HPC as a whole is really providing to customers, but also the unique value that Intel is really providing to the market to be able to correct and improve these codes as they're operating on customer sites. So now let's move on to the scale category and talk about Intel MPI, or the Message Passaging Interface Library. And again, what this is trying to do, what MPI is trying to do, is to chop up the code. So you have a long application that takes a long time to run. You're trying to chop it up into bite-sized chunks that the CPU and the nodes can execute to, and then effectively scaling that across multiple nodes. So this allows you to get the best performance you can by effectively chopping up the code and delivering that for your customers. And what Intel does, again, is we use Intel MPI to optimize third-party codes, to optimize open source codes, and then we give those optimizations to those providers, to those developers, so that they can release it to their customers. So what that means for you is that as you're talking to customers and they're running, say, Ansys Fluence, or they're running a different scalable code, we already have Intel MPI already built into that application, so your customers can be assured they're getting the best performance possible by running on an Intel system. This is the unique value that Intel is really providing to the ecosystem. And then we also have tools as you're scaling your code to get a better analysis, better visualization tools to be able to see how that code is actually being scaled. Is there something that's not scaling correctly? Is there some inefficiencies built into the fabric operations? Is there some inefficiencies built into how the code is parallelized and scaled across multiple nodes? This Intel Trace Analyzer and Collector tool helps you see what some of those inefficiencies are so you can get better performance out of your code. And so what are some of the advantages of being able to use these analyzers? Cluster inefficiencies is not something you can directly observe. You can't walk up to a cluster and say, oh, that one's not operating efficiently. You have to have some tools to be able to analyze and record and collect information from that cluster to figure out if the MPI is behaving correctly, is the fabric interconnects behaving correctly, how is the code being scaled, and how is the cluster operating as a whole. You need tools to help you do that, and Intel provides those tools to developers, to end users, to learn, are their clusters operating at their peak efficiencies? And let me remind you, clusters are very complex systems. We're bringing together sometimes thousands of compute systems, thousands of interconnects, thousands of memory modules, and different types of users are interacting with this, from application developers to the cluster architects to the actual users themselves to system administrators that are granting access to the clusters. Very complex operations surround a cluster as it's operating very complex workloads. So Intel does provide a tool known as Intel Cluster Checker. And so this allows you to collect diagnostic data from the cluster. It allows you to apply different types of rules that can allow you to operate that cluster in a more effective way, and it suggests fixes to allow that cluster to be operating again at that peak efficiency levels for these very complex systems. And so I also wanted to show you some of the performance gains, again, that we're seeing by using Intel tools. Intel Parallel Studio XE is a software package that includes all of those tools that you previously saw in the build and analyze and scale categories. Intel Parallel Studio packages that up and delivers it to developers, delivers it to end customers so that they can get the most use and the most efficient use out of the Intel tools. But it does provide real performance increases to real applications out in the marketplace. And as I mentioned before, software is really that thing that helps tape together data, hardware, and business use cases to really get value for customers. So if we look at some of the numbers here, for artificial intelligence on the Google Cloud Platform as an example, we saw a 23x improvement in AI performance with Google Cloud. We saw a 10x improvement for energy use cases in Schlumberger applications. And we can go down the list and just see that our Intel tools provide tangible value to the marketplace that wouldn't be there before if Intel didn't provide that value. So Intel really does focus on providing real value, real software value add for the customers as they're deploying their applications. And keep in mind, Intel, as we develop these Intel tools, are feeding the optimizations directly to the developers, directly to those third-party ISVs to help boost how ready they are to be able to deliver the best performance to their customers. So again, Intel has those deep relationships, those deep investments with certain ISVs, and we've actually invested again in over 200 codes that we've directly optimized. So not only again are we optimizing the codes, but we're giving the optimizations to those third-party providers, those developers, those open source communities, so they can more easily deploy it to their end customers. So what that means for you again is that as your customers are using these applications and they're using them on Intel systems, they can be assured that the best optimizations are being fed to them as fast as possible. And keep in mind too, Intel does develop full solutions. So as customers want recommendations for what types of systems they want to build, what types of performance can they expect for a certain application, it's nice to have a reference point of, oh, this system that was configured this way gives you this kind of performance. So if a customer wants to build that same solution using that same reference architecture, they can compare what kind of performance they're getting, and if they're not, then they can make some tweaks, look back on our reference architectures to see what kind of tools we were optimizing for it, and make sure they get the best performance. And so we want to remind you that HPC customers are running a very diverse set of workloads. Not every workload is optimized the same. Not every workload uses the same hardware. It's very important to have that range of options, that flexibility built into your system that Intel provides to get the best performance. In future courses, we're actually going to be putting all this together. We're going to show you very specifically in manufacturing and education, how are we combining different hardware features, how are we combining different software features that give the best performance. And what you'll note in those courses is it's not the same across every single workload. It's important, again, to have that range of options because every workload requires different types of optimizations, different types of hardware. So keep that in mind as you're going through the manufacturing and education courses to learn what are the different Intel tools that are helping to optimize that performance. And we do want to leave you with what is Intel doing in the future as well. We've seen this slide in previous courses. We call this Intel's 6 pillars of innovation, and it's focused in on 6 areas that we're trying to invest in for better performance out in time. I'm going to zero in on the simplified programming bucket for this course and talk about one API. So the whole idea behind one API is as customers want to start using CPUs and GPUs and neural network processors or FPGAs to help accelerate their codes and they find use cases in using those architectures, one API helps to kind of tape all of that together. So today what happens is, let's say a developer writes a code for a CPU, but then they want to port that code, that use case, over to a GPU. That's a very complex, time-consuming, and costly process. So what one API tries to say is you can write your code on a CPU and then easily port that over to a GPU or over to an NNP or over to an FPGA, depending on what that customer wants to use. And we're building this on top of open standards. So we're not locking you into an Intel processor or an Intel GPU or an Intel FPGA. The customers are free to use whatever type of architecture they want from whatever provider they want. And that's the beauty of one API and the fact we're building on top of open standards and making it easy to use those different architectures out in time. And of course, we're going to build in the Intel optimizations using our Intel tools like the compilers, like the math kernel libraries, like the cluster checkers and the Intel MPI to make sure that those optimizations are built into one API as you then port it to different types of platforms. So as a takeaway, I want to leave you with, again, all HPC workloads are not built the same. They require different hardware, they require different software ISV relationships, And so Intel really does provide that unique value towards these applications. So again, as you're talking to your customers, remind them Intel provides very unique software value to the marketplace to be able to optimize those codes. And Intel has numerous investments and initiatives working directly with different ISV providers to accelerate HPC performance for their applications. And so for next steps, we want you to go talk to your customers about the Intel software value add. What are the tools that we provide to help optimize their applications? Talk to your customers about what is the direct relationships that Intel has with third-party ISVs to optimize their applications. Talk to your customers about how easy it is to get these optimizations built into their codes so they can already have the best optimizations built in. They don't have to tinker with their code. They don't have to worry about performance because Intel is taking care of that for them. So thank you for taking this HPC on Intel Software 101 course as part of the Intel on HPC Solution Competency. And as a reminder, please take the quiz at the end of this course to get credit.